Gravity is often introduced as the localized force pulling a dropped object to the ground. But look straight up, past the atmosphere. The vacuum of space operates under the exact same physical constraints. A satellite gliding in orbit is governed by the same mathematical reality as a falling stone. This is Newton's universal law of gravitation. It is the mathematical bridge between local terrestrial physics and celestial kinematics. The mechanics are remarkably simple. The attractive force between any two objects is strictly proportional to the product of their masses and inversely proportional to the square of the distance separating their centers. Using only this single inverse square formula, we can build a complete mechanical model of the universe. This unification proves that the exact mechanics dictating a falling apple scale flawlessly to control the solar system. We start by deriving local acceleration. By substituting Newton's second law of motion, force equals mass times acceleration, into the universal gravitation equation, we calculate exactly how Earth pulls on objects. The small mass of the falling object mathematically cancels out. We are left with the formula for G. Local gravitational acceleration depends entirely on two constants, the total mass of the Earth and the radius of the Earth. That calculation assumes we are standing on the surface. If we drill down deep into the planetary mantle, the physical variables change. This graph maps the variation of gravity from the Earth's core to the surface. As we move outward from the absolute center, acceleration increases on a linear slope. The outer mass shell above our depth functionally cancels out its own gravitational pull, leaving only the mass beneath us to exert force. It peaks at exactly 9.8 meters per second squared at the surface radius. Above the surface, the distance radius continues to increase, but the Earth's mass is fixed. The acceleration drops off according to the inverse square law, creating a steep decay curve as we move further into space. Therefore, 9.8 is not a universal constant. It is simply the location-dependent maximum output of the core gravitational formula, occurring precisely at the planetary boundary. This chart translates the decaying force of gravity into a map of gravitational potential energy. The vertical axis represents energy, with 0 positioned at the very top. Extending downward is an infinitely deep negative space. In astrophysics, potential energy is defined as exactly 0 only at an infinite distance away from a mass. When a physical object is brought close to a planet, it rests deep within the negative values of this potential energy well. The mathematics require a negative sign because gravity is strictly attractive. To pull an object outward to reach the 0 line of free space, you have to add energy to it. Any object sitting in a gravitational field inherently possesses negative potential energy. This abstract mathematical well describes physical reality. It is the boundary defining whether an object is permanently trapped by a planet or free to drift into the wider cosmos. Escape speed is the precise minimum kinetic energy required to overcome the negative potential energy of the well. By adding positive kinetic energy until it perfectly touches the 0 line, the total system energy becomes exactly 0. We set kinetic plus potential energy to 0 and substitute their formulas. Solving for velocity yields the escape speed equation, the square root of 2 times local gravity times the planetary radius. For Earth, that velocity is approximately 11.2 kilometers per second. It relies solely on the planet's mass and radius. The mass of the escaping object itself is mathematically irrelevant. Now consider an artificial satellite. We inject it with a kinetic energy that is deliberately lower than the escape threshold. Its total energy falls back below the 0 line, mathematically trapping it inside the negative well. Any state where the total energy remains negative is defined as a bound system. Satellites in orbit are bound in continuous freefall. They possess enough horizontal velocity to constantly miss the Earth as gravity pulls them down. Orbital motion is not the absence of gravity. It is a permanent, mathematically negative energy state trapped within the gravity well. We can scale these same bound energy systems up to macroscopic planetary bodies. The massive anchor of our own solar system is the Sun. Kepler's first law of planetary motion states that bound planetary orbits are not perfect circles. They are ellipses, with the Sun sitting off-center at one of the geometric focal points. Kepler's second law dictates that a line drawn from the planet to the Sun sweeps out equal areas in equal amounts of time. Watch the sector smoked out when the planet is physically closest to the star. To sweep out the exact same area over the exact same time when further away, the planet must change speed. It dynamically accelerates when near the Sun and decelerates when far away to conserve angular momentum. Finally, Kepler's third law establishes a strict mathematical rule. The square of a planet's orbital time period is directly proportional to the cube of its orbital radius. These three laws of macroscopic kinematics provided the exact observational proof Newton needed. They verified his inverse square law of gravity in the real world. We have modeled three massive physical states: structural internal acceleration, absolute energy thresholds for orbit, and macroscopic elliptical kinematics. This composite view shows how these seemingly distinct phenomena are inextricably linked. The central spatial variable, the radius distance, drives the mechanics across all three systems. Calculating a satellite's precise trajectory or predicting the behavior of a falling apple requires the exact same baseline physics. Looking at the physical system of Earth, we see the mathematical framework acting in reality. Gravitation remains the inescapable foundation of celestial mechanics. A single inverse square equation governs the entire architecture of the universe.